Hey everyone. So in this video, we're going to talk about what a determinant of a matrix is. So because we're going to be computing the determinant for a matrix, you need to be familiar with what a matrix is. And if you're not, no problem. Just go check out some of our other videos where we talk about what a matrix is, what its properties are, the operations on a matrix and so on. So let's get started. So I'm going to show you a collection of numbers which looks very similar to a matrix, right? You can see this. Now it has 3 rows and 3 columns. But if you have noted keenly, you see that there is one difference from what we generally write as a matrix, which is in general, for a matrix, you have square brackets around the numbers. In this case, I've used the absolute value symbol, right? I've got 2 straight lines, and in between that, I've got the numbers. So these 2 straight lines are the symbol for determinant, right? So when you take out the square brackets and instead replace that with these 2 straight lines, it becomes determinant of a matrix. And the determinant of this matrix is minus 3. Now, why is it minus 3? How do we compute it? We'll get to that, right? Okay. So, this is another matrix, 2 by 2, and the determinant of that is 10, right? Okay. Another matrix, again a 2 by 2 matrix, and you see that the determinant is 0, right? Okay, interesting. And now we have a bigger matrix. It's a 4 by 4 matrix, and the determinant is 3. So, what do you observe about these 4 cases that I've shown you? One, that obviously I've replaced to compute the determinant or to show you or represent a determinant, I've replaced the square brackets with straight lines. Two, each of these matrices is a square matrix or are square matrices, right? 3 by 3, 2 by 2, 2 by 2, 4 by 4. So one important thing to note is that you can only compute determinants of square matrices. Okay. The third thing is we have taken this big matrix, for example, a 3 by 3 matrix here, and we've converted it into one number, right? 2 by 2 matrix into one number, 4 by 4 matrix into one number, and you could have a 100 by 100 matrix, and if you compute the determinant, you end up with one number. Now that number here could be a real number. It could also be a complex number. If you're not familiar with complex number, don't worry about it, right? And we'll have videos on, when we talk about number systems about complex numbers. But basically, it's a matrix becoming a number. So that's a determinant, right? So let's go to a general matrix. You have this general matrix here, A11, AMM. So it's got M rows and M columns, which means it's an M by M matrix or has an order M by M. It's a square matrix clearly. So the determinant of that, and you can see I've replaced the square brackets with, the absolute value symbol or 2 straight lines, is a value K. Now K, in this case, if you replace this with numbers, you end up with a number here, right? But for now, I'm just using K as a placeholder or as a representative number. So what a determinant is it is a function, right, that takes a square matrix and maps it to a unique number. And what you mean by that is every matrix has only one determinant, right? So it does not mean that 2 matrices cannot have the same determinant. They can, but this particular matrix can only have one determinant. So that's what I mean by this. And we've already seen that it's only applicable to square matrices. So expanding on this a little more, how it's written is the determinant of A, and you can also write it as f of A, which is what is used to represent a function, but I like to call it det of A, which means determinant of A is a function that maps a square matrix to a unique number. So M here is the set of square matrices and K is the set of numbers or scalars. And the determinant is a function that takes something from this, that's a square matrix, and maps it or converts it into a scalar. If you're not familiar with set, don't worry about it. We'll cover sets in a different set of lectures. And so the determinant of A is K, or determinant is a function. And even if those of you who are familiar with some basic coding, right, you know how functions are. So you have a function that takes in a value. In this case, it takes in the matrix, and what you end up with is a scalar. Okay. So a few more interesting things to note, and we will have a separate video about properties of determinants, right? But just to introduce a few important ones, I, I already talked to you about unique, but just to specify, each matrix has only one determinant. And if the determinant is 0, the matrix is singular, right? What we mean by that is you cannot compute the inverse of the matrix. And if you're not familiar with what an inverse is or how do you compute inverse, check out some of our other videos. Now you can compute an inverse with a determinant as well, and we will cover that in a separate video. But you can compute an inverse without a determinant using elementary operations, and we have got a separate video on that. So you can check that out if you're not familiar with what a singular matrix is. But this is a very interesting way to check if a matrix is singular. You compute the determinant, and if it's 0, well, you know the matrix is singular or it does not have an inverse. Okay, so now let's look at a couple of very simple cases where computing the determinant is actually very straightforward. It's a simple function, right? So let's go through that in this case. So let's start with a 1 by 1 matrix. Now we know a 1 by 1 matrix is a square matrix because it's got one row and one column. So you have a general matrix here, A11, it's one element, and the determinant of that, which is written as the absolute value of A11, it's not absolute value though. You can get confused for a 1 by 1 matrix, but it's the symbol for the determinant, and that is equal to A11. So that element itself is the determinant itself, right? So if you have a 1 by 1 matrix, well, that number A11 or that element in that matrix is the determinant. So that's very simple, right? Makes sense? Okay. Let's take it to a slightly higher level. So you have a 2 by 2 matrix, right? 2 rows, 2 columns. So the determinant of this matrix, and I've written it again with the notation, what you do is you take A11 and multiply it by A22. Then you say minus A21, A12. So the determinant of A is A11 into A22 minus A21 times A12. That's it. So that's a very simple function, and you can see what the function is, right? The function basically takes in this matrix, right? You take the entire matrix in, and then it takes the elements of that matrix and converts, by performing a set of operations on the elements, converts it into a scalar. And for a 2 by 2 matrix, the operation it performs is A11 times A22 minus A21 times A12. All right. So this is a very useful formula because whether you're solving a system of 2 by 2 equations or trying to invert a matrix, trying to check if a system of equations is solvable, trying to check if a matrix is singular, 2 by 2 matrix, this is a simple function. Just do A11 times A22 minus A21 times A12, and you've got the determinant. If it's 0, the matrix is singular. If it's a system of equations and this is 0, the system of equations cannot be solved, and so on. And we have a separate video on how a system of equations can be solved with matrices. So if you're not familiar with that, please check it out. Okay, so let's do some practice now, right? Now, before that, just a note, we will cover how to compute determinants of 3 by 3 matrices and more general cases in a separate video, right? But I've not done it here because I think it's a topic that deserves to be treated separately. It's a little more complicated, so we'll treat it separately. So now compute the determinant of this, right? Just pause the video for a second and compute it, right? So what is it? You do 2 into 1 minus 1 into 1, right? Which is 1. So you've taken this matrix and you've converted it to a scalar. And if you remember the operations, right, AD minus BC, there is no other way you can compute any other determinant for this function. Okay, what about this one? So minus 5 into 1 minus 5 into 1. So it's minus 5 plus 5, which is 0. And so we know this matrix is singular, right? Okay. And now looking at the third case, so you see here that you had a 1 by 1 matrix 7. Compute the determinant of that, and so the determinant of that is 7, right? The determinant of a 1 by 1 matrix is just the number itself. Okay. Perfect. So hopefully with this, you're now familiar with what a determinant is, and you've also understood how to compute the determinant for a 1 by 1 and a 2 by 2 matrix, right? And we'll cover in a separate video how to do this for a 3 by 3 matrix and for more complex cases, right? And also look into properties of determinants and applications and so on. right? But first, go ahead to teachyar.com and take a free quick test, right? That'll help you solidify your concepts a little more. It'll give you a little more practice. And as we know, with practice, math gets better and better. And I've dropped a screenshot of that test here. So to take the test, scan the QR code here, right? And you can take the test on your mobile device, or you can go to this link, which we have dropped in the description and the comment section. So click the link or scan the QR code and take the test. And at the end of the test, you'll also get, it'll be graded automatically, and you'll also get some good feedback, right, on this topic. So that should hopefully help you learn even more. And please subscribe to the TeachYaar YouTube channel so you get notified as we put more and more content out.